You watch it on Edmodo tonight. All right. Here we go. Number 8. Number 8. Hush, hush. Let's go ahead and start right here with our matrix, all right? And then we'll decide if it's ideal gas law, combined gas law, or what it is, okay? Look here. The volume noted in the figure. This is a big gas cylinder. Have you ever seen these on the backs of trucks? Okay, where are they taking them to? Hospitals, doctors' offices, industry, factories, places that use gases, all right? The volume contains nitrogen under a pressure of 4.972. I'm going to write that here. 31.8 degrees Celsius. There are people talking back there and it's distracting me and I've got to get through this. All right? 304.8 Kelvin is my temperature. They want to know the number of moles right here. Uh-oh, what about volume? What's my volume? Yeah, y'all have to be careful. The volume might be given to you over here, or some kind of important information might be given over here. All right, you got to use it. All right, here we go. Let's decide what we're using. Is there a change in conditions? Are we heating? Are we cooling? Are we changing pressure or volume? No change. Are we dealing with moles? They want to know moles. Yeah. So we are certainly dealing with moles. So what are we going to use? Mr. Ideal Gas Law. Okay? So here we go. PV equals nRT, but I want to solve for n. So let's rearrange the equation. How do I get n by itself? Divide by RT. So n equals PV over RT. All right, let's look up pressure. Times volume. These numbers they give us are nuts, aren't they? What do they give us such crazy? Oh, here's where we have to decide the R value. How do you do that? Sorry. What did I tell you earlier today? I only told you one thing, and y'all worked hard on trying to see this. It was on these notes. Go back and look at your notes. What? 9.583. I'm just reading this number over here. All right. Look, I'm flipping to this for a minute. Where do I decide what my universal gas constant is? Based on my pressure unit. What's my atmospheres? What's my pressure unit? Atmospheres. What is the R value that goes with atmospheres? It's R value number 2.0821 liter atmospheres per mole Kelvin. Do you see how I choose that? I look for atmospheres because that's my pressure unit. So I'm going to write R exactly like it's written on the green sheet. I'm going to do my new and improved Kelvin temperature. And what do I do here? And what do I do here? Yes. And what do I do here? I'm multiplying my numerators, and I divide by both of my denominators. So 4.972 times 9.583 divide by 0.0821 multiply those, divide by this, and divide by this.
What's the top one?
9.583. 304.8. Because in the calculator, you've got to tell it to divide by this 304.8. Otherwise, it puts it back up here again. Everyone try that. Don't let tomorrow be the first time you try this calculation. What? 4.972 times 9.583 divide by 0.0821 divide by 304.8. All right, very good. This answer, all right, atmospheres cancel, liters cancel, kelvins cancel, moles in the denominator of the denominator, so that means it's in the numerator, and by the time I get through my significant figures, I will be able to choose answer B, which matches this. That's a great idea. I was thinking about giving you a clue on the test, but I think it's a better idea if you just use what I gave you today. So how about you use this right here, okay? That way you still have to do a little thinking, but you know what to do and you're using your notes. The only clue word on this one is moles. That's your clue. If you see moles, right on. Right on. Okay? Number 9. Number 9, all right, we have a mixture of gases. We have a total pressure. Total pressure is a key word. That's Dalton's law. That's Mr. Easy law. Okay? What's our, yeah. Gases. All right. Look, guys. We have a total pressure of what? 860. What are the 4 gas pressures? 220 plus 220 plus 110 plus D, question mark. All right, set that up right now. Set that up on paper. Write a word problem right now. Write a word problem to go with number 9. That does this. All right. This is the word problem I came up with, right? Total is equal to gas A, gas B, gas C, plus gas D. And I'll just call that X. All right? All right. The correct answer, when you take 860 minus is 310. Is that what y'all are telling me? All right, very good.
Oh my God, stop. Did you see that?
I'm recording. I'll look at the videos later. Number 10. Number 10. What's a key word that tells us the type of problem number 10 is going to be? What's the key word here? 10. Partial. That's Mr. Dalton's law of partial pressures. All right. This is tricky. Read this out loud. Neely. Go ahead, Neely.
A sample of three gases is at atmospheric pressure, and the partial pressure of gases X and gas Y are studied. What is the partial pressure of gas unit?
Very good. If I know X, I know Y, I know Z, what do I need to know to be able to solve for this? I need to know the total pressure. They must give us the total pressure. What is the total pressure? They give it to us, but it's a little tricky to find it. What's the total pressure? Who can figure out what the total pressure is? No. Don't throw something at my son. He's not wearing goggles. Then what? Check this out. It's in the first part of the first sentence. The total pressure is given to you in the first part of the first sentence. Very good, Ashley. Atmospheric pressure in this unit is what number? 760. All right. We know that standard atmospheric pressure is 760 mmHg. So now, does everyone know what our total pressure is? All right. This pressure is 260. This pressure is 320. Josh, get up and go get it. All right. This is 260. This is 320. The total is this plus Z must equal 760. Does everyone see that's the word problem we're trying to figure out? Is that easier? I'm getting 260 from reading this number off the graph. I'm getting 320 because I'm reading this number off that graph. Yes.
I guess the answer is C. 180.
You read it off the graph. Just a second. I'm working on Chris. And this you got from reading the problem. Do you know why I'm giving you graphs, guys? You're going to see this in the SAT, on the ACT. The graphs is a big, graph reading is a big part of your future. Number 11. So what's the answer? The right answer is 185. Now, does 185 work there or not? No, but it's the closest one, isn't it? Now, why am I making a mistake? Is it because it's hard reading graphs sometimes? So do you think maybe I have this number? I have one of the numbers wrong, but it doesn't matter. Look how far apart the numbers are, right? They're giving us room for error. Okay? Dalton's law. Dwayne, you are too loud.